All right, we're going to do a little note taking on systems, but we have to figure out first what's a system. And I think sometimes when we come to this part, that seems to be the most difficult part, is just understanding what a system is. Well, a system is more than one. If you are dealing with any kind of problem, if you're setting up a business, if you're designing something, there is more than one condition, there's more than one limit, there's more than one thing you have to think about. So a system is a problem that has more than one limit. If I am working at Burger King and I need to sell 25 hamburgers an hour to make a profit, I can't hire just one person. That's a limit. I have to have more than a little bitty stove. That's a limit. Systems are about limits to a problem. And so what we're going to do is we're going to have a collection of equations about these limits, and we're going to put them together in a system. And then what do we have to do to solve it? Well, we have to find the values that make everything true. We have to find the values that make every single thing work. So what's a system? It's more than one problem. It's more than one thing. It's more than one limit. All right. So we're going to start off by doing three things to solve equations, of systems of equations, and that's graphing, substitution, and elimination. Let's look at graphing first because that's always my favorite. What is a graph? A picture of the answers. A graph is a picture of the answers. So right here we have one system that has this one equation that has this line, and one equation is this line, and together they are a system. Well, where do you think? Use your common sense. Where do you think the answer to this system is? Well, there's only one, and it's right there where they connect, where they intersect. It has one solution, and at that point right there, everything is perfect. That number, those values, will make everything true about the system. All right? Let's add some more words to this because vocabulary is everything in Algebra 2. Consistent. What this means is this is a system that has a consistent, normal, average answer. There is an answer. It's consistent. This is a way you want your profit and loss to look in your business. It's independent. The two things are independent of each other, which is what makes it such a nice system. It has an answer. They're independent of each other. How many solutions? One. How many solutions? Well, they don't even hit each other, and if they don't hit each other, they don't have a solution. So whenever you see two parallel lines, there is no solution because they never intersect. Now, if this is your business and this is your profit and this is your cost, are you in trouble? Yeah, because your two things don't ever cross. Your profit and your cost don't ever cross. You are in a lot of trouble. All right, let's do some more words. Inconsistent. What's going to happen to you if this is your business? You're going to go bankrupt. This is an inconsistent system. It doesn't work. It doesn't make sense. Okay? What if you were doing your little drawing and you were graphing and all of a sudden you realized that the two lines you had were the same line? How many solutions are there? Infinite. Because every single little point, every single value on the whole thing is a solution because everything will make it true because they're the same line. Infinite solutions. Let's get some vocabulary. They're dependent on each other. You don't want a business where you only got two limits and they're dependent on each other. You're not going to be successful. They're dependent. Are there two things? Yeah. There's a system, there's an equation that's running this thing, there's an equation that's running this thing. There are two limits. How many solutions are there? There are two solutions, because how many times did it intersect? Now what you'll find is maybe one of those solutions doesn't make sense, but there are two solutions. What about this one? How many solutions are there? Just one. Because where is a solution? A solution is where they intersect. A solution is where they intersect. So graphing, nice and easy, always my favorite. All right, our next one, we're gonna touch on it because I want you to think about the vocabulary of what we're doing. The second method is elimination. Well, gee, I wonder why we're calling it elimination. Oh yeah, we want to eliminate a variable. We want one of the variables to go away so that we can deal with the other one. We'll look at what we have here. 2x plus y equals 4, x plus negative y equals 9. If you add these two equations together, what happens to the y's? What is y and negative y when you add them together? When you add them together, there's 0. They're gone. You just eliminated the y's. There are no more y's. So I could finish the problem, couldn't I? Well, let's look at this one. Okay. How could we get one of the variables to go away? Well, if I'm going to add this together, will adding 4x and x together do anything for me? Probably not. But what if I add negative 2y and positive 2y together? Because that's what I'm going to do. I'm going to add the two equations together, and then what happens? Oh yeah. Now, I don't want you to say I crossed them out or they canceled. What I want you to understand is, what is negative 2y plus 2y? Well, that's 0. Negative 2y plus 2y, that's 0. They're just gone. They add up to 0, and I don't need to write it down. So I don't really want to hear the word cancel. I want to hear that you understand that negative 2y plus 2y is 0, and so they're not there anymore. So what do I have left? I have 5x equals 10. Well, I know how to do that. If I divide both sides by 5, I get x equals 2. I only have one variable. One of them was eliminated, so I'm in good shape. I can solve it. X equals 2. Now, if x is equal to 2, what's y? Gee, I don't know. I got rid of it. All right. How about we take whichever equation we want to. I think I'll just take the first one. That's easiest. And substitute in 2, because I know x equals 2. If I substitute in that 2, well, look at that. 8 minus 2. Oh, that's stuff I can solve, isn't it? I only have one variable, so I can solve it. I can move the 8. I can solve it because there's only one variable. So elimination, it eliminates one of the variables so that I can find an answer. And I'm still going to use it and substitute it back in to still do the same thing. I only have one variable. Okay? What if I worked really, really hard and I figured out a way 2x minus 2x is 0, but what happened was, look, everything went away. 0 equals 0. What is the solution? Infinite. Anything will work. It doesn't matter what you put in there. It's going to work. But why? Well, let's change these. This is standard form. This is a standard looking form. Let's change this to y equals mx plus b. Look at that. They're the same line. You couldn't really tell it over here, but when you changed it to y equals mx plus b, you could actually see, look, it's the same line. Oh, that's not bad. So if they're the same line, you already know they're infinite. So if I get 0 plus 0 equals 0, anything will work. Anything will work, and there are infinite answers. Okay. What if I worked really hard, and I got 0 plus 0 equals 12? Well, that's just dumb, isn't it? What do you think? We've seen this before. You have seen this before. What do you make of getting 0 plus 0 equals 12? There's not any solution. Something's wrong. Something's really wrong. This is broken. Let's do that thing where we change it to y equals mx plus b again. If we worked really hard and we changed these to y equals mx plus b, look what happened. They have the same slope, but they have different intercept. What does that mean? They're parallel. They're parallel because they have the same slant. So there's no solution. So you need to understand why there's no solution. All right, our last one we're going to hit today, just real quickly, is substitution. You should have already done some substitution, but let's think about it. We're going to isolate a variable in one of the equations, and we're going to substitute it into the other equation. Now, substitution is so useful. You're going to use it everywhere. So this is one that you really need to understand. But we're going to isolate a variable in one equation, and then we're going to stick it into the other one. All right, so I have two equations because this is a system, and a system has more than one. Okay, so I have y equals x plus 1, and I have 2x plus y equals 7. Do I already have a variable isolated? I do. Look, y is all by itself in this equation. So I'm not going to do any more work. I'm just going to stick it in there. So y can really be written as x plus 1. So how about, I've already got it isolated. How about I just put it over here in place of y? Look what I got. I have 2x plus x plus 1. I only have one variable, and that was the whole goal, wasn't it? I only have one variable. Combine the 2x plus x, subtract the 1. Oh, look, 3x equals, I know what that is, x equals 2. So substitution is taking something from one equation and substituting it into the other. All right. So this is the equation we've been working, this is the system, sorry, that we have been working on. So y equals x plus 1. I found out that x equals 2, but what do I do to find y? Well, I'm going to substitute again. I'm going to take that x equals 2, and I'm going to put it into an equation. Which one should I use? Doesn't really matter, but I think the first one is really easy. Look at that. If I take y equals x plus 1, and instead of x, what do I write? 2. Then I have y equals 3, and I am done. So substitution is really, really valuable. All right, so you have a very quick little six things just to check and see if you remember what is the solution. And I'll warn you, danger, Will Robinson, danger. Systems seems to be one of your most difficult issues. And we're going to get it all lined out, and it's going to be good. So thanks.